Okay, we have an ice cream problem. Ice cream problems are always good problems, right? Says here that the annual per capita consumption of ice cream in pounds in the United States can be approximated by this normal distribution over here to the right. And they give us our information of our mean is 19.7, standard deviation is 4.6. What is the largest annual consumption of ice cream that can be in the bottom 9%? So let's draw this a little bigger here. So there's my mean, and I want the bottom 9%, which if I'm going to look this up in a z-table, I'm going to put that in decimal. So what I'm doing is this formula, and I have the mean, 19.7. I have the standard deviation. I can look up the z value in my z-table, and I'm trying to solve it for x. So if I go to a z-table and I look within the table, the probability part, for the value closest to 0.09. So I'm looking all around, round, and it looks like the closest value that I can find to 0.09 is 0.0901. So I read the z value, which is negative 1.3, look up, 4. So negative 1.34, so put you back over here, over there. And so that means my z value here is negative 1.34. And so now I just go through the algebra, like multiply both sides by 4.6, x minus 19.7. I get negative 6.164. And then finally, I add 19.7 to both sides, and I get 13.5, which would be this value. So think about these logically. That makes sense, right? Because it needs to be below 19.7. All right, the second part, you're doing the same thing, but it's a between value that you're looking, values, I should say, that you're looking for. So it wants to know what two values does the middle 80%. So the middle 80%. So once again, I draw my normal curve. I have my mean right here. And so what I'm looking for is within this curve, the middle 80%. So all of that's the middle 80%. So I'm looking for, again, I'm just doing the same thing as I did on the last one. I'm looking for those x values. Well, if this is 80% and I have to cut off half of it, I cut it in half, so 0.8, 1 minus 0.8, I get 0.2. I have to half that because half of it's going to go here and half of it's going to go here. And remember, all of these probabilities should add to 1, and they do. So I'm going to look up in the table the value closest to 0.10 to find the z value. And do you remember this other value, if you're actually wanting to look it up in the table, you're looking from the bottom all the way up to that value. So you're actually going to be looking for 0.90. But you're going to see a little trick here in a second. So let's find this bottom value, the 0.10. So I'm looking for the value closest to 0.10, and it looks like 0.1003 at a negative 2.8. All right. Well, the other one was 0.900. If you really are understanding, you don't even have to look this up. It's going to be 1.28 positive, because remember, this is symmetric. Okay, so whatever value I get down here, this negative value, the positive value will be the same value. So this is my z is negative 1.28. This is my z, which is 1.28. And then you just do exactly like we did on the other. We're going to solve for x. So negative 1.28 equals x minus 19.7 over 4.6. And I'll leave it to you to go through the same steps we just did to get x equals 13.8. And then over here doing the same thing, but a positive 1.28. X minus 19.7 and divided by 4.6, and you should get x equals 25.6. Oops, I didn't mean for that to go away. 25.6. So again, seems logical. 13.8 below 19.7, 25.6 above 19.7.